Hey, welcome to The Explainer. Today we're diving into some really cool brand new research that, well, it pretty much flips everything we thought we knew about AI teamwork right on its head.
All right, so let's get right into it. For a long time, the common wisdom in AI has been pretty straightforward. You want a smarter AI, you just add more AIs to the team, right? The thinking was, you team them up and their power just grows and grows, exponentially.
I mean, it makes perfect sense, doesn't it? This whole idea is called collaborative scaling. You take one smart AI, and then you add a few more to the mix. They can work together, bounce ideas off each other, check for mistakes. It's gotta be better, right? This has been the bedrock assumption for building bigger and better AI. But what if that's just wrong? A brand new study from some heavy hitters at Google and MIT decided to really challenge this idea. And honestly, what they discovered is a total game changer. Turns out, throwing more AIs at a problem isn't the magic fix we all thought it was. And this is where it gets really interesting. They found that the success of an AI team has almost nothing to do with how many agents are on it. Nope, it all comes down to one thing: the job you give them. The type of task you're trying to solve, that changes everything. So check this out. For some tasks, teaming up AIs works incredibly well. We're talking about jobs that can be split into smaller pieces and worked on at the same time. Think financial analysis. In those cases, a well-structured AI team saw performance skyrocket by a staggering 80.9%. That's a huge win. But, and this is the big but, on other tasks, it was a complete disaster. We're talking about jobs that have to be done in a specific order, one step after another, like planning a trip. When they added more AIs to those tasks, performance didn't just dip, it nosedived. It plummeted by as much as 70%. Yikes. So you have this massive swing, right? An 80% gain on one task and a 70% loss on another. How is that even possible? It's not just a tiny difference, it's a completely different universe of outcomes. Figuring out why this happens, well, that's absolutely critical if we're going to build AI we can actually rely on. Okay, so to solve this giant puzzle, the research team, we're talking folks from Google Research, Google DeepMind, and MIT, put together this just massive, super controlled experiment. Their goal was to find the fundamental rules of AI teamwork once and for all.
And when I say massive, I mean it. They didn't just run a few tests. They tested 180 different configurations. They used 5 different team structures, 4 different kinds of tasks, and models from all the big players: OpenAI, Google, Anthropic, you name it. And the really smart part? They locked down everything else. The prompts, the tools, the budget, all standardized. That way, they knew they were only seeing the effect of the team structure itself.
And this is maybe my favorite part, how they actually structured these AI teams. It wasn't just a random free-for-all. They actually mirrored the way we humans work together. You've got the lone wolf, the single expert, then there's the second opinion approach, where few AIs work on their own, and then you compare answers. You've got a centralized team with a project manager AI bossing everyone around, and finally the decentralized brainstorm, where all the AIs are just in a room talking and trying to agree on something. So after all that, after crunching all the numbers from those 180 experiments, they distilled it all down to 3 basic principles. Think of them as the fundamental rules of AI teamwork. Okay, rule number 1. It's called the tool coordination trade-off. Basically, the more complicated the tools a job needs, the worse a team of AIs performs. Why? Well, they get stuck in what the researchers call a coordination tax. It's just like in a human office. If you have too many meetings just to figure out who's doing what, you never actually get any work done. It's the same thing here. Now, rule number 2 is a bit of a mind bender. They call it the capability ceiling. It turns out if a single AI is already pretty decent at a job, let's say it gets it right about 45% of the time, adding more AIs to the team is a waste. You actually start to see diminishing returns, or it can even make the performance worse. The hassle of coordinating everyone just isn't worth that tiny extra bit of brain power. And that brings us to the third rule, and this one is wild: error amplification. Without a good manager, mistakes don't just happen, they multiply. Get this, in a team where the AIs just worked on their own and didn't talk, that second opinion model, a single tiny error could get blown up, amplified by more than 17 times in the final answer. But if you had a project manager AI checking the work, that amplification dropped way down to a much more reasonable 4.4 times. That's a huge difference. So, what's the big deal with all this? Well, the most important thing here is that this research doesn't just point out what's wrong, it actually gives us a blueprint, a playbook for building better AI from now on. And I mean a literal playbook. Using these three rules, the researchers built a framework that can look at a brand new task it's never seen before and predict the perfect team structure for it with 87% accuracy. That is insane. We're moving from just guessing and hoping for the best to actually having a science of building AI teams. So here's the bottom line. The question we should be asking isn't how many AIs do we need? That's the wrong question. The right question is, what's the right team architecture for this specific task? It's all about matching the team to the job. Need to do financial analysis? You want a centralized team with a manager. Exploring the web? A decentralized brainstorm is your best bet. But if you're trying to do sequential planning, turns out a single AI working alone is often the smartest way to go. This is a massive gift to anyone building AI. It means developers can now move from guesswork to a real science of scaling these systems. They can design AIs that aren't just more powerful, but are also way more efficient and reliable. No more wasting time and computing power on team structures that are just doomed to fail. Which leaves us with one last kind of mind-blowing thought to chew on. Think about it. Coordination taxes, communication problems, errors spiraling out of control. These aren't just AI problems. These are human problems. They're the same challenges any project manager in any office deals with every single day. So if the rules of good teamwork are the same for both us and our AI creations, what does that tell us about the nature of intelligence itself? Maybe, just maybe, these principles are a universal truth for any kind of mind anywhere.